of the vector. It doesn't actually normalize the vector itself. So the correct way to do it is to go and say, hey, this guy has to be normalized. So that's how you call it. You call the function. You don't call the function. You just call the attribute. Now another error I was doing. I was not assigning the steer to the actually clamped. So I was sort of doing it like this, right? In my code, I had vector3 clamp activity, but this, I never assigned it to anything. I just clamped, made a copy, but never assigned it. So I had to actually assign it to something. And these two errors, or normalization and actually assigning the clamp value, I had to go and do it throughout. So same with difference. Again, same with the steer here. Again, somewhere here as well. So through my code, I kind of went and changed that. And this gives me a fairly nice behavior. If I can hide this. I always hate when this bar from Zoom gets over my... Okay, so now I have a flock that sort of behaves the way I would expect it to. Also, now the values in the flock make a lot more sense. So the distances are a bit more logical, 1.5, 2. They're related to the size of the particle itself. Okay, and let's try to do the border. So we finish up also this part. So we have in our thing something to do with the border, and there are a few ways of doing the border. I'm gonna try to do it in a very simple way. So I'm gonna create a sphere, and let's call this the border. Let's place it in the origin, and I'm gonna scale it. Okay, so let's think of this as being our sphere, right? Where we have our computation. I don't actually need to see it, so I can disable the mesh renderer, because what I'm going to use is actually the sphere collider. Okay. Now, what I changed as well with my prefab for the void, I've added a rigid body. Okay. And I need a rigid body to detect collision, right? Otherwise, there is no collision. And in the rigid body, you have also a function for this. Now I have to do the same for this guy. So for my border, I'll need to go and create a rigid body. And what we're going to do, we're going to say, hey, this guy is actually kinematic. So he's not an actual object that moves. He's kinematic. Okay? And because he's kinematic, it means, and again, I don't need to use gravity. And to be honest, because he's kinematic, he's not going to move at all. So let me show you how that works. I'm going to, for a second, ignore that he's kinematic and turn on the mesh renderer. And I'm going to actually place it somewhere in space. So you kind of see what happens. So now if I go into play mode, that guy is going to have collision. Well, you see? And he's going to collide at some point. Well, he already collided, but for some reason he stopped in midair. Yeah. So what we're going to do, again, we're going to reset this guy. No, not this guy, the border. Okay. And in our rigid body, we're going to say, hey, he's kinematic. And I'm going to turn off the mesh renderer because I don't actually want to see it. Now, what I think the best way to do it, it's in the actual void itself, right? In our script, I have now the border, and to be honest, I don't really need it because I'm gonna do it in a bit in a different way. And I'm gonna use a function which is on collision exit. Okay, and all the voids now are colliding with our border. They're colliding because they're inside of the border, right? So we want, whenever we exit the border, to do something. Okay. So the first thing we're gonna do is we need to check who we're colliding with, right? And we're going to say, well, give me the name, and we're going to ask if the collision collider name is equal to border. Let's test that this works. We're going to say debug log, and in here void is outside border. Okay, and honestly, I don't even need the border. This function, I don't really need it. Okay, so let's see if that works. Now let's look at the console, and again, let's go in play mode. So initially, all our voids are within the border. Come on, get out! Really? That's funny. They're all not getting out. Huh? Okay, something is not working. Let's make our border slightly, and let's check that the spelling is correct. Let's make this, I don't know, let's make it fit. Okay, so it's working, right? So we can see our voids are getting outside. Let's do something as well. I think for now, because I actually want to see the border, I'm gonna turn on the mesh renderer, but I'm going to make a new material. I don't know, let's make it, I guess, orange. And let's make it transparent. We made it transparent. Fine. So we can actually see our border for now. And I'm actually gonna turn off the floor for now. Okay, so I can see my void getting out. It works. I don't need the floor for now. Okay, perfect. So it works. That's great. But at this point, what I want to do, I want to calculate the vector so that points me back to the center. And again, this is quite simple because the vector pointing from towards the center, it's the current position of the void minus the center of the collider, right? And we have our position. So we need to get from the collision, the collider, from the collider, get a transform, and then get the position. And I know that's 0, 0, 0, right? Okay, so that's good. And now we need to move. Right, so to do this, I think the easier way to do it, yeah, we can do the same. So we can do, let's try to see what makes sense. Because we also want to multiply it by something. Yeah, so we want to apply, we're gonna apply a force. And yeah, but we first have to seek it. So we're gonna have to do similar, a new seek vector. And to be honest, I think we can just copy it. Let's copy it from one of our functions here. I think the better way would have been to say, hey, here is equal to, and because we have our seek function target, yeah. So we need in here steer equals seek, and in here move towards border center, and then steer. I think we're probably gonna have to force here. We're gonna have to somehow make this max force much bigger, right? Otherwise, it's not gonna move that well. So I don't know. Let's multiply it by 10. Ideally, this should be a variable that we can set. So it could be a public variable that can be moved towards border. But for now, I'm gonna just hard code it. So you can change this number to something. And let's see, it should do it, like at this point. Well, yeah. Let's try to do it more drastical. I think it's not, it kind of does it, but it's not powerful enough. Um, let's try something ridiculous. There you go. Huh? Not really. Okay, but you get what I'm trying to do. It's just my math probably is off. Uh, let's see if I'm doing it correctly. In my position, I need to draw this. Whiteboard. So I'm here, and that's the border. I'm here, and now I have a vector that points there, and I have another vector that points there. And if I want the vector in between them, is position minus center. So that gives me that vector. It might be that I don't need to do I might not need this vector. I might just say, hey, move towards. Instead of here, I might just need this. Let me see. Yeah, target minus position. Okay, so definitely I don't need this step. Let's see. Stop share and then share screen. Really weird. Okay, but you get what I'm trying to do. So yeah, that's the way to do it. Yes, that's the other thing we need to do. Because no, you just apply them because you calculated and then you multiply it by a number, which is what we're doing. What if I don't plant it? What if I do it like this? Okay, and when we apply the force, where are we? Yeah, acceleration plus equals force. And then in our update, now in our update, it will work because you'll automatically do it. Velocity plus equals acceleration. Oh, let's see. I think that did it. Yeah, there you go. They no longer are going beyond the border. Cool. That worked. Does it make sense? Sure. Yeah. Absolutely. That's a great question. A fantastic question. Let's model a custom mesh. And obviously, I'm moving in 2D, but you can move in 3D. But I'll show you how you can bring your own border. So let's model something. Oh, come on. And now I'll remember my password. Jesus. What did I set it up? Oh, no. That's the problem. You always forget your passwords. Come on. Thank you very much. 1 second. Let me reset my password. Even better, but I should probably remember what my password is. Okay. Okay, I've resetted my password, so that is not a problem anymore. Okay, where's my Maya? I'll really remind me later. Come on. This guy is annoyingly slow. Sorry, this is my shed computer. I don't really use it that much. Do you have a model made? Hmm? Or anything? I think I have something cooking. So this looks fairly decent. Okay, and for the sake of, let's make it smooth. Very nice shape. Where are you? Do we want low poly or do we care if it's low poly or not? Yeah, let's keep it low so we don't have that many polygons. Okay, so I have now my custom mesh. So what I can do, I can export selection. Let's drop it to the desktop for now. And I'm going to use OBJ. Okay, now let's go to our Unity. Let's make a new folder. And here, some border. Very nice. And it's flipped. uh, we should have probably, in the export settings in Maya, not flip it. Where the hell is it? Well, you can change the axis in Maya to match Unity, but anyway, for now it's flipped. So what I want to do in my border, you see here where I have my mesh renderer in the filter, I'm gonna change to this new pcube1. And again, being a bit more clever, if you want your things to be named, I should have probably went in here and call it border or something. So it's not named pcube1. Yeah, let's do it correctly, because then at least you see correctly how to do things. Yes, export. Let's go into Unity. Re-import. Boom. Then here, my guy should be named not pcube1. Ah, really? Okay. Yes, yes. And I'm gonna import it again. Yeah, now it's named border the way I would expect it to be named. And this guy, border. Looks cool. Now I have to change. You see here where it says free collider. I'm gonna need to remove this and add a mesh collider. Okay. And now the trick is that it's actually using the mesh, but you need to give the mesh. And you see he picked up the mesh automatically. He picked up the border. Okay. I'm gonna also rearrange them around. So I want to have my rigid body after my mesh collider. Okay. So now it works as well. And let's make the border material a bit nicer. So now if I go into play mode, there you go. It sort of goes and stays within that border. Now, a better question will be, how can we make these particles actually stick to the border? And that's a nice homework if anyone wants to do it. Cool. That's a pretty funky border. Okay, cool. I'm gonna stop there. I think it's almost 9 o'clock anyway. I'll share the code, the stuff I did today. And I think from next week, we can start to look at ways to almost analyze the output of our computation, to start to introduce some idea of analysis and basic ideas of intelligence. So what can we do with the computation that can embed some intelligence in this, because we have two computational models, both take decisions. One is very agent based, right? So you have little particles taking decisions where to place themselves in space. And the other one is more neighborhood based, conditions of who's connected to who, and you're playing with energy, you're playing with grids and walking through them, and it's perfect. We need to start to think of ways of analyzing things and thinking, okay, now that this is computing, what's the output? And what can we do with that? And how can we embed some type of intelligence so we can make these agents or the cells take decisions that are a bit informed based on conditions, okay? Sure. I'm gonna let you search for it. There is a very simple way of doing it. You have to search for the mesh vertices. So on the mesh, on the collider mesh, you need to seek what is the closest point. I can't give you all the code. You have to do a bit of work. But think of the mesh topology. So now our mesh has a bunch of vertices, right? So if I share my screen, and again, this is a very simple mesh, but obviously I can convert this to a much more tessellated object, right? But this guy, essentially within this, I have the faces. So each face gets me a centroid. So that information exists within Unity as well. I also have the individual vertices. So I can calculate where I am in the vertex or the face center. Now, if you want this to have more information, obviously you need to tessellate this. So you can always subdivide. So you can go model, where the hell is it? I'm not a big Maya person. Where the hell is the add subdivision? Modify.
You can find it also under the custom tab in the main tab with geometries and primitives with the icons. The tab with the icons. Yeah. In the middle, organize the vertices. Like next to that, next 3 icons. Next, the other one.
Yeah, add subdivision. Yeah. Okay, so now this object has a bit more information on it. There was also in Maya, you would go into, if I remember, modify, where the, I totally forget. You can go and add from there as well, but yeah, that works too. If I go in here and add 2 divisions, like I guess this mesh now has a lot more information, right? So I can again export this custom border, then go to my Unity geometry, import. Come on, it's quite funny. I don't know why the re-import is not working. It should have worked. There you go. Now it works. Just be careful a bit, because whenever you introduce something with a lot of points, you have to also be careful, because all of that takes computation power. But now you can search on the border, what's the closest point? So if I go into my collision in here, I can go vector 3, mesh. And in here from the mesh, you have to look at, you need a vertex. So that gives me the list of vertices. Vector 3, and that's a list. Mesh points. Well, you have to do something in here, but it is something. So you'll get a list of all the vertices, and then you have to search from the list the one that is closest to you, and that becomes your what you want to seek to go towards. But yeah. Hmm? Yeah, but you sort of have to get from the collider, the mesh filter, then from the mesh, and it's a bit in there. It's somewhere in there. The mesh has all this information. You have to seek, and yeah, up to you to sort of figure it out. Cool. Yeah. You can also do collision between them as well. No, you have to do it by yourself. Come on, I know you can do it.
Okay.
No, really,
just,
you have to
give
figure
us a hint.
you have to figure things a bit by yourself, because I'm not going to always be here to solve it.
Yeah,
So,
we're trying, but we.
I know,
we
keep
have
trying.
to
That's what I'm saying.
also to develop that, in a faster way, because we have a final presentation in
I
Thursday.
don't care about your final presentations. I care about you learning to do things. So
Yeah, we're learning, I guess. So
yeah.
if we
So
can
for
have-
me, if you do a great final presentation, but you haven't learned how to do these things by yourself, you don't get much out of it. So, and again, I know you're constantly under pressure to do presentations and do well in the course, but for me, the goal is not that. So yeah, I'm gonna let you figure it out. And if you tried in 5 ways and you haven't figured it out, then I'm gonna help you. Sounds fair?
Can I ask another question?
Sure.
I actually look into the lightweight mode for Unity, but do you suggest me to have to take a look of that? Because I think the problem is that in lightweight mode, even the particle can simulate like tons of particles, like such as vibration process. But is that because of the particle is not actually mesh, so we cannot actually realize it?
It is sometimes like this. And again, like you guys are jumping 10 steps ahead. This is something that I want to show a bit later. So we're actually gonna switch at some point from using. Right now we're sort of coding the behavior, but we're gonna search and to use the Unity physics. because
Okay.
Unity already has a physics engine built in.
Yeah.
And
Okay.
it's a really powerful engine. And recently they also implemented Havoc, which is a really, really powerful engine.
Yeah.
And we're gonna use that. And what's interesting, because in the Havoc system, you already have a lot of these things made. You just need to call functions.
Okay.
And if you want, and if you're curious, I can share with you where you can use for examples.
Okay. Thanks.
So if for example, we go and search for you can start already to play with this, to load it. And it's a really fun engine. Like, honestly, it's an amazing engine.
Yeah, it's very interesting.
Yeah, and it's real physics as well. So it's based on practical physics simulations.
Okay.
And actually, a lot of the examples are on GitHub. And again, if you want to jump into it, you're welcome to go and use it. Somewhere in here, you see a physics sample. Yeah. No, not this one. There are tons of examples, and a lot of them do all type of collisions and also quite advanced joint systems. Yeah, they're quite nice. And if you want to do, that's one that actually I think it relates to one of the themes. The
Okay.
planetary systems. But yeah, if you want to go into it, but honestly, it takes a while to, it's not the easy one to understand. Like setting up this entity component system, it's a different way of coding as well. If you want to jump ahead, go ahead. Give it a go. Download the examples and try to see if you understand how it works.
Okay.
So I can share this with you, the code. Cool.
Okay, thanks.
Okay, everyone. Well, good luck today. And I'll see you on Monday, I guess. Have a good weekend. Bye.
Thank you.